Well, maybe select all of them, actually, now I think about it. Let's try that. Okay, so I think that's what we're supposed to do. We're supposed to select all of them. And so, right, and so we are done. So hit apply or OK. And we're going to make another boundary condition called body. And this one's also going to be a wall. And I think it says wall. Ooh. Just looks weird. Okay, I believe it is wall. And we want to make sure this is a no slip wall and option smooth wall. So I believe that's right. Let's cross our fingers. Okay, I might have done something wrong. So follow the tutorial because I am not sure what these red things are. Okay, so we want to change the outlet. So if you double click on outlet, we need to change its boundary type to outlet and set its boundary details as below. So he says we want to make sure it's subsonic, average static pressure, relative pressure 0 pascals, 0.05, average over whole outlet.
Those red arrows are coming from
the primitives?
Yeah, which primitive you selected.
So, yeah, let me go back.
Each model is different, so going back and just selecting, just deselecting some, usually on A, B.
Last time I just selected one of these, not all of them.
Yeah.
I think that'll work. Yeah. So we'll just do one of them, apply, see what happens there. Okay, still got something. I think I did 2B last time. All right, well, hopefully it's just one of them. We will find out. And then the inlet, so we modified the outlet. Now we're going to modify the inlet. Make sure it's inlet, and then set to a boundary type inlet. And the boundary details, subsonic, normal speed, and then for this, and then this is something you can change. So right now it's set to 1 meter per second. I'm going to say miles per hour, and in the tutorial here he says 30 miles an hour. So you can change this to whatever you really want to, what speed you want to be the airflow going over it. So we're going to do 30 miles an hour, and then medium intensity 5%, and then total temperature is probably fine. So hit OK. And okay, so now let's see. Body's already being used for another boundary. Let's see here. Default domain. Oh, right. I'm going to get rid of this guy. See if that fixes it. Oh, maybe it's... Well, that's symmetry. I think it's... Oh, I have them both referencing wall, I think. It's default exterior. That might be what we're looking for. Okay, yeah, we don't want this to be wall. We want the body to be default exterior. Okay, I found what I did wrong. One of the things, at least one of the things I did wrong. When you're setting the boundary of the body, you want to make sure the location is default exterior because it's selecting this guy right here, as you can see. If I try to select the wall on this, which I think I did previously, you can see a little bit of green showing through up here. So I don't want that to be the body. The body I want to be this guy. So I'm going to hit OK. I think that should be good, because then wall is set to wall, which is the green up here. Okay, so that should be good. Okay, so now we're going to set up the solver by clicking this button up here, the solver control. And the only thing we're going to change is the time scale. So we want to make sure it's high resolution, first order, 100. Yeah, this is going to take a while, by the way. 100 iterations. Mine last night took like 30 minutes, 40 minutes. Maybe I did something wrong, but it converged. I got a solution, but it took a lot longer than I expected. So hopefully yours doesn't. Okay, so time scale control. This we're going to change to physical time scale, and we're going to set it to 2 seconds. And that's really all we're going to change here. So we're going to hit OK. And we're going to define the solver run by clicking this button, define run. Now we're going to tell where we want it to save our run. So once again, we can go to the same file location, class, and we're going to call it class save. Okay, so when we finish this, the CFD solver manager will automatically open. And we're going to verify the file and the working directory are correct. So we want to make sure, yeah, we're going to drop it there. And the working directory is here. So we're going to start. And it will solve, which in this case, I'm not going to wait for it to finish because I have no idea how long it'll take. So then the last thing in the lab is it just shows how to show a contour plot of your results, which is very, very simple. So you can just follow the last few steps to see how to do that. It's pretty straightforward how to do this. The reason we mesh it in HyperMesh is that we already are familiar with HyperMesh somewhat, and it's easier to get that mesh that we're looking for. But in the end, you can get quite a good-looking result of this by following the steps. And it's best if you do it with your own car, like we mentioned, because then you can then show that in your presentation. Yeah, instead of having to do it twice, you can just do it once. So here is a picture of the one that I did earlier. This is the result that I got in ANSYS. So, yeah, are there any questions? Okay, if you get to the point, I would suggest that if you get to the point you're ready to solve and there's about 10 minutes left in class, save everything, because mine took a lot longer than I expected to solve. And so hopefully it'll take just a few minutes, but it might take a lot longer. So you may not even have time in class today to run it, but you should be able to get everything else set up by then. Okay? So if you have any questions, we're going to be walking around helping.